So we're just coming back from lunch and we're doing this last problem number 1 before we are done for today. And we are going to, I'm using that kind of blank space off to the side of the right to write some notes about what the trig functions are. And so I want you to kind of use that space with me. I normally make a point to label these notes, what they're called. So this section in your textbook, which I know we haven't really used our textbook that much, but this is called inverse trig functions. So we are doing inverses. Do you remember back in unit 1 when we talked about inverses? An inverse operation undoes something. So it undoes what you just did, or you can also think of it as like going backwards. So some common inverse operations you guys have been using for years that you maybe didn't know they were called this is like addition. If I add something to a number, the opposite of that is subtraction, right? Duh, right? You've been doing that on equations for years. Same thing with like dividing. If you divide by something, you can get rid of that by multiplying. So those are inverse operations, they're opposite of each other. And then one that we've been using most recently is like an exponent. So like if I have x squared, what undoes that is a square root. Ooh, a square root. So what I'm telling you here is these inverse trig undo a trig, undo the original. So for example, if I have sine of something, what undoes it is sine to the negative first, inverse sine. So let's write this. Normally when we see sine, we do sine of an angle equals a ratio, opposite over hypotenuse. That is, I'm doing sine of an angle and I get out a ratio. The inverse operation is sine to the negative first, and it's going to be the undoing of that. When we learned about, I'm going to come fill this in a second. I just meant to talk about this earlier and I forgot. Underneath this, I want to write when we did inverses before, I'd give you an equation like y equals x squared plus 1. I'd say find the inverse function. In that, we switch the x and the y. So we do an equation, you don't have to write this down, but I'd say like y equals x squared minus 1. And back in chapter 1, you guys would be like, all right, let's switch it. And we'll say y or x equals y squared minus 1, and then you could solve that. Do you have some brief memories of that? We're going to do that exact same thing here. We're switching our x and our y. So instead of saying like x and y like normal, when we did the inverse, it became y comma x. This is similar to the little parentheses I just wrote up here. So I wrote angle comma ratio. When we do the inverse sine, we're not doing the inverse sine of an angle. We're going to do it of a ratio. We're going to do it of like O over H. And my answer is going to be an angle. It's going to be theta. So this time I put in a ratio and I get out an angle. My answer, when my question is sine to the negative first of something, my answer there is always an angle. So what I'm giving you in these problems is the ratio, and you're telling me at what angle does that ratio happen? At what angle does that ratio happen? Okay, I could go into like way more depth, but I'm just going to do one more thing with you and just give you a little brief understanding on why what I'm about to tell you is true. So underneath that, there's a special quadrants that we look at for all of these. And I only am going to talk about sine, cosine, and tangent because the ones that go with them follow the same rules. So sine, we're only going to look at 2 quadrants. I told you to get your unit circle out because if I'm doing inverse sine, I only care about these 2 quadrants. Inverse cosine, I only care about these 2. Inverse tangent, I only care about these 2. And to figure out which quadrants we get to use, we're going to look at the graphs. Now, I'm introducing this to you because I believe in teaching you the best way of doing it, the most correct way. Will I ask you to write the graph out? No, but I think it helps explain. It's not just arbitrarily picking these 2 quadrants. It makes sense based on the quadrants, based on the graph. So our sine graph could be here. And we know that sine starts middle, ends middle, it goes high, and then it goes low. That's a bad graph. We're used to just drawing 1/2 of sine, right? I'm going to go back in the other direction too, so I've got a little bit more to work with. Would have gone down and then up to go backwards. When I do inverses of sine, I only care about this part right here. I only care about from negative pi over 2 or negative 90 to positive pi over 2 or positive 90. Those quadrants are the first quadrant. So this represents the first quadrant. And then if I went to the negative angles, which quadrant would that be in? There are negative angles in 3, but I don't want to go all the way to 3. I'm just going less than 90. So I'm going to just go into the fourth quadrant. Quadrants 1 and 4 are where we're looking at sine. If I'm going to zoom in on the graph, I'll zoom back out in a second. But do you see how this passes the horizontal line test? Like if I were to find any single x, it has only one y value that goes with it. That makes it a function. If I were to move this over to the other part, if I were to move it to the second axis, the second quadrant too, that would look like this. And do you see how if I were to draw a line, there are 2 different points there and I wouldn't know which angle to look at. Am I looking here or am I looking here? Like, I don't know. So we're only looking at the part of the graph that gives us exactly one answer for each one. So I'm only looking at quadrants 1 from 0 to pi, which would be like 0 to 90. And then from 0 to negative pi, which is negative 90 or positive 270. So that's why I'm looking at quadrants 4 through 1. Okay. We'll see what this looks like in action in a minute. All I'm saying is I don't want you to find an answer in quadrant 2 or quadrant 3 for sine. Does that make sense? Do not look in quadrant 2 or quadrant 3 for sine. Now cosine is different. It is not going to be the first and the fourth quadrant. Let's look at its graph. Cosine starts high and then it goes to the lowest and then it ends high. And then I'm going to just reverse it just so we can kind of see the whole graph. If I were to do the first and the fourth quadrant, just like I did for the last one. Oh, no, I think I did that too far. I think it's just here. Do you see how this is exactly what I told you we can't have in sine? If I were to like look at this ratio, it goes to 2 different angles. That's a problem. It doesn't pass that test. If I scoot it over, though, to quadrants 1 and 2, then I have all of these independent lines. See, there's nothing crosses, nothing crosses. It's all new independent information. So I'm looking at quadrants 1 and 2 here. So this goes from 0 to pi or from 0 to 180. If you want to think about it in radians or degrees, it doesn't matter. Why is that the second quadrant on the bottom? You thought it was like what? Yeah, it goes, if you're looking at me, it goes 1, 2, 3, 4. Sine is in 1 and 4, and cosine is going to be in 1 and 2. Are you confused because of all students take calculus? This isn't my unit circle. This is a graph of sine and cosine. Okay. Right. Okay. You guys are thinking about like, I am in quadrants 1 and 4, but this is not like a unit circle graph. This is just a normal sine graph where a normal cosine graph just does its little wave throughout. This is 4.4 stuff. This is when we did our transformations of graphs. There's technically, if you're thinking about quadrants 1, 2, 3, and 4, I'm in all 4 of them right here, right? Because it doesn't matter about quadrant there. When we talk about quadrants, we're only thinking about the unit circle where I'm going from 0 to 90 to 180 to 270. Those are the quadrants I care about. This is just a general sine graph. This is just a general cosine graph. Remember that cosine and sine go from 0 to 2 pi, but do you see how like they repeat numbers? If I only go from 0 to pi, I'm not repeating any numbers. These are all like new unique points the whole way. But when you start wrapping back up, ooh, now this is the same as that point, and I can't look at that. Does that make a little bit more sense? If not, I need you to just stick with me because we're gonna, once we do it on the unit circle, it's gonna make a little bit more sense. What I'm telling you here is just like when we go look for our answers, we're only looking in these quadrants because you will find the answer in other quadrants, but because of the range that I care about for inverse sine, inverse cosine, inverse tangent, it is sitting right there for you. You're welcome. Those, because of the range that I'm talking about, I don't want you to overlap in the other quadrants. I only want you to look at those two. Again, we'll do a problem in a second and it might make more sense. And we just don't, you don't really know what you're looking for yet because I haven't given you an example yet. I'm giving you background so we don't have to do the background later. The last one is tangent. And I know we didn't spend a lot of time with the tangent graph, but this one is the same as sine because the tangent curve is always in between negative pi over 2 and positive pi over 2. And so it is also like sine where it goes in the first and the fourth quadrant. Quadrant 1, quadrant 4. Okay, so we have the quadrants in mind because we're about to go find out what's going on. Let's go over to letter A. It says sine to the negative first of root 3 over 2. So sine to the negative first means that this is a ratio, and what's my answer going to be? What am I looking for? An angle. Good. My answer is going to be an angle. We know that sine, we just decided, has to be in quadrants 1 or 4. So we're only looking in quadrants 1 and 4. And sine is always my y value. So we're essentially going to our unit circle and say, okay, where is y, positive root 3 over 2, in quadrants 1 and 4? At what angle? At what angle is my y, root 3 over 2? 60? Or pi over 3? Does everyone see where there's the only place that there's a positive root 3 over 2 in quadrants 1 and 2 is at 60? There's another one on my unit circle though, in its second quadrant, right? What angle is that? What other angle has this answer? 120. Now, the reason we're not using that is because I don't want multiple answers. So I'm restricting myself to only look at quadrants 1 and 4. That's why all of us know what angle we're talking about. Because if I don't tell you that our restrictions are in quadrants 1 and 4, you may be thinking about 120 the whole time and I'm thinking about 60. So this quadrant thing just tells us that we're all looking at the same spot. Okay, the next one is also sine to the negative 1. So that's my inverse. And it's of negative 1/2. So I'm going to go look for where it's negative 1/2 for my y. And again, we're in quadrants 1 and 4. What angle, Jared? 330. And that's the same thing as 11 pi over 6, I think. I'll just write or, you don't have to write and. And that's it. Those are my answers. Like we just did 2 problems. Those are it. You okay so far? Okay, tangent to the negative first. So again, I'm looking for an angle. I'm looking for where tangent is 1. Now, tangent is not an x or a y that we're just going to go like look at and be like, that's what it is, right? Tangent is y over x. So I want an angle that when you divide y by x, you get 1. That means x and y should be the same number. Which angle am I looking for? Does anyone know? That's what the X's and the Y's are. What angle is there? That's 1, but I want to be in quadrant 1 and 4. See, that's why we determine which angle, which place we're in. So, Brooke, I heard you ask what quadrant are we in. That is 1 and 4, which is what we talked about over here. So I just didn't say it first. That was my fault. Which is the same thing as pi over 4. That one took a little bit more work because it wasn't just a search and find, but personally, I feel like we've been doing so many of these tangents, cotangents that like, I know that 1 goes with 45. I know that 1 goes with root 2 over 2 over root 2 over 2. So you need to start kind of picking up these hints, I guess. And then the last one's cosine -1 of 0. Cosine, oh, this one's different. This is in quadrant 1 or quadrant 2. Cosine is x. So which angle has a cosine of 0 in quadrants 1 or 2? 90. Very good. Okay. We're going to do more practice with that before we get to the rest of this. So maybe on Monday we'll do like some more practice all together. That's what I got through with F period today. So we're just going to stop for today. We're going to finish these notes, maybe do a little bit more of this practice on Monday. And that's that. Any questions? On Monday, your 4, 6, and your 4, 8 are due.